All right, so I'm going to do one more from number 2 there. And let's take a look at E. So once again, we have reference angle 48 degrees. And in reference to that angle, we have the side opposite, and then we have the side adjacent. So in reference to this angle, the relationship that compares the opposite and adjacent is tangent. So tangent of theta is equal to opposite over adjacent. And so now I can fill in what I know. I know tangent of 48 is equal to x. I don't know the opposite, but I do know the adjacent. And this trig function works out a little nicer to solve than maybe that last one did. Because in this case, really all I need to do is multiply both sides of the equation by 5. And those cancel out. And so really I'm left with the calculation x equals 5 times tangent of 48. And so the answer, when I type that in, so let's go ahead and do that again in your calculator. So take your calculator and all you're going to do is type 5 tangent 48. I like to get in the habit of closing that parenthesis. And we get 5.55 to 3 sig figs. So 5.55 to 3 sig figs. Okay, so those are 2 examples of the 2 types of trig functions that we're going to need to be able to solve. There's a third one coming up here, a third version where we solve for an angle, but you have to be able to notice how in this one, notice how the part we're solving for was in the denominator of the fraction, and this one, the part we were solving for, was in the numerator. Those are 2 cases where you have to be comfortable solving for wherever that piece is at in the fraction. Okay. So let's keep moving here, and let's look at number 4a. Find to 2 decimal places all unknown sides of these triangles. So this is where we're kind of putting all the pieces, a lot of pieces together rather, to find all the missing pieces. I'm going to set up each of the functions or each of the ratios, and then I'll let you calculate those and come up with your answers. But for this one, so we have reference angle 35, right? So this is our reference angle. That means this is the opposite, this is the adjacent, and this is my hypotenuse. So let's see, first thing I can do, I can solve for x. Let's go alphabetical. So I'm going to solve for x first. And so in reference to 35, that's the opposite, and I know the hypotenuse. So I want to use the hypotenuse because that's a piece of information I know. So the relationship that relates the opposite and the hypotenuse is sine. So sine of theta is opposite over hypotenuse. And I need to now fill in the pieces I know. So I know the angle. I know the angle measure. The opposite side I do not know. The adjacent side. The adjacent side I do know. Not the adjacent. The opposite side, or the hypotenuse, rather. I know the hypotenuse is 5. Okay, there we go. So now we have another, this is a situation that we need to be able to solve. This was kind of like that, just that very last one we did, where all I need to do is multiply both sides by 5. And then in your calculator, you need to type in 5 sine of 35. Okay, and then that would get you your answer to 2 decimal places. Okay, so at this point, I'm going to let you do that, and I'm going to go ahead and set up my my second ratio, and then you can finish solving that one as well. So for the second one, I'm solving for y, which is the adjacent. So I still want to use the hypotenuse because that's a piece of information I know. I still want to use this reference angle. So I can set up another trig function that relates the adjacent to the hypotenuse. That's cosine. So cosine of an angle is equal to the adjacent over the hypotenuse. So filling in what I know the angle. So cosine of 35 is equal to the adjacent, I don't know. That's y over the hypotenuse, adjacent over hypotenuse, 5. So this one turns out to, as a similar calculation to that, to the other calculation we just did. So multiply both sides by 5, and then I get y equals 5 cosine of 35. And again, in your calculator, you would type in 5 cosine, and then your calculator shows parentheses. I would get in the habit of showing those or closing those parentheses, because later on when we make more complex calculations, that'll be a good habit to be in. So for the rest of these, you are using trig functions to set up an equation to solve. Notice in each of these, you are given an angle and one of the sides, right? So you have to use trig functions to set up and solve the missing piece. Now, once you know one of the second side, you could use Pythagorean theorem to solve for the third side, but you need to practice. You need to practice using the trig functions, setting up and solving the trig functions. Okay, so just a brief explanation here, finding angles, and then I'm going to have to jump to another video. So finding angles. All we've done so far with our trig functions is finding sides. So we can also use them to find angles, but that's when we use the inverse functions. So inverse sine, inverse cosine, inverse tangent. So that's when I don't know the angle, but I do know two sides, right? So notice in this case, we are trying to solve for theta, the angle. And so I still want to focus on, in reference to this angle, this side is the opposite, this side is the hypotenuse. So the opposite and hypotenuse, that is a sine function. So sine of theta is equal to the opposite, which is 2, over the hypotenuse. Okay, well, in order to solve for this then, when I solve for an angle, I have to use the inverse of that function. So that is noted as that little -1. That is what that means, the inverse sine, and then I take the inverse sine of whatever that ratio is. And that is equal to the measure of my angle. Okay? So inverse sine of 2/3, let's do that calculation. So inverse sine is you gotta do second, right? So second sine, and then 2 divided by 3, close the parenthesis, hit enter. 41.81, so on, would be your answer to part A here, 41.81. Okay, so let's take a look at part B there. Maybe. There we go. So part B, same thing, right? In reference to this angle, we have the opposite and we have the adjacent. So tangent of theta is equal to the opposite, 10/7, over the adjacent, right? So 10/7. So again, in order to actually find the angle, I have to take the inverse tangent of that ratio. Right? So inverse tangent of that ratio. When we, again, calculate that, just make sure you are using second tangent, and 10 divided by 7. Let's try that again, 10 divided by 7. And we get 55.0079. So to 3 sig figs, 55.0 would be appropriate. And that is the angle, right? So when you write that down, that would be, you want to make sure you write that in degrees.